All right, today we're going to talk about different lines in a triangle. The first type we're going to talk about is actually a segment, not a line, and it's called a median. And a median in a triangle is a segment that joins a vertex of the triangle to the midpoint of the opposite side. So think about what that says. Take one of the vertices of a triangle and then draw a segment from there to the midpoint of the opposite side. It would look something like that. So in any triangle, how many medians are there? Well, since we're drawing it from a vertex to the midpoint of the opposite side, and we have a choice of 3 vertices, we have 3 medians in every triangle. So those would be the other 2 for this particular example. All right, at this point, I'd like you to go to your iPads, open up GeoGebra, and don't go into the calculator section, the algebra section. Just do the geometry portion of it so you just get a nice blank canvas to work on. And I'd like you to construct a triangle in GeoGebra. And then I'd like you to construct the 3 medians of the triangle. And what you should do is pause this video for a minute while you do that. Go ahead and do that. And then come back to it. Okay, hopefully you paused, you did this in GeoGebra and you came back to it. Now if you were having trouble with it, the important thing you have to know is to connect a vertice to a midpoint of the opposite side. What you're going to need to do is construct the midpoints of all 3 sides of your triangle. So after you have your triangle constructed, you need to go ahead and go to the point tool and choose midpoint and then tap on each of the sides of the triangle and it'll make a midpoint for each side. Then you go to the segment tool and make a segment and tap on one vertex and the midpoint across from it, and then do that with the other 2 vertices as well, and you should have 3 medians. Now you've probably noticed that all your medians are concurrent, which means that they all met at the same point. All 3 of them meet at one single point. And that special point is called the centroid. Centroid. And there's some important properties related to the centroid of a triangle, where the medians cross. So, I'd like you to go back to GeoGebra with that same sketch. So you already have the triangle and the 3 medians. And I'd like you to construct the point where they intersect. So you'll have to go to the point tool and choose intersect, and then tap on 2 of the medians, and it should create the intersection point of all 3 of them. If you like, you could even label that point centroid, if that helps you remember it. All right, after you've got the centroid constructed, I'd like you to measure the distance from one of the vertices to the centroid, and then measure the distance from the centroid to the midpoint of the opposite side. So not for all 3 medians, I just want you to do this for one of them. The centroid splits any one of those medians into 2 parts. I want you to measure each of those parts with the measuring tool by measuring the distance or the length. You can go ahead and repeat that for the other 2 medians, or if you want to just do it for one, then I want you to move your triangle around and notice the connection between those 2 measurements, those 2 distances. This would probably be a good time to pause and then go ahead and do that. And when you're finished, come on back. Okay, hopefully you've constructed all of these and measured everything in GeoGebra, and you've noticed something about the 2 distances of any one of the medians. And remember, a conjecture is something that, it's a sentence that explains what you notice in your sketch. So hopefully you noticed that the bigger piece was twice the length of the smaller piece. And so your conjecture might have said something like this. The centroid is located at a point 2/3 of the distance from the vertex towards the midpoint of the opposite side. Now, because that's 2/3 the distance, that means the other piece is 1/3. So we could say the centroid is 1/3 the distance from the midpoint, and it's 2/3 of the distance from the vertex. So it's dividing that segment, that median, into a ratio of 2 parts to 1 part. Let's take a look at an example where we can actually apply this. Let's say P is the centroid of triangle ABC, and then I'm giving you some information. So let's list a little bit of this. A to P is 10 units long, so I'll write that in there. Now I'm going to stop and not look at the other information for a minute, and I'm going to go over to the questions. We want to find the length of PD. So in your picture from P to D. Well, from what we noticed in GeoGebra, if A to P is 10, P to D should be half of that, or 5. The bigger piece of any median is twice as big as the smaller piece. So if I give you the bigger piece, you divide it by 2 to get the smaller piece. So PD is 5. And then if I ask you what is AD, well, that's the length of the whole median, so you add those together. 10 plus 5 is 15. All right, let's look at the next piece of information. P to E is 6. Notice that's the smaller piece of this median. So if I give you the smaller piece, you know the bigger piece is twice as big. So if E to P is 6, P to B must be 2 times 6, or 12. And then finally, the last bit of information that I gave you is that CF is 12. CF is the length of the entire median. Let me mark it over here. C to F equals 12. Now remember, the point P is 2/3 of the distance from C, or 1/3 the distance from F. So the easiest way to calculate the two pieces is let's calculate the smaller piece from P to F. That's going to be 1/3 of the whole thing. So if I know the whole thing, the whole length of the median, I'll divide that by 3 to get the smaller piece. So that tells me that F to P is 4. And then once I know the smaller piece is 4, I know the bigger piece is twice as big as that. So 2 times 4 is 8. So just to summarize, let's see if I can highlight these. If I give you the longer piece, you divide it by 2 to get the smaller piece. If I give you the smaller piece of the median, you multiply by 2 to get the longer piece. And finally, if I give you the entire length of the median, divide it by 3 to get the smaller piece, and then double that or multiply that by 2 to get the longer piece. Okay, hopefully if you've been paying attention, you'll be able to do the worksheet which you're going to get now.